Director of Developer Relations. We're also joined by Joe Anand. And Joe, do you want to introduce yourself?
Yeah, I'm Joe Anand. I'm the product manager and also the president of MecSoft Corporation. I've got 30 plus years in the CAD/CAM industry, starting with GE Calma. I don't know if any of you in the audience remember GE Calma, but it was one of the first 3D CAD/CAM systems in the world. It was in San Diego, bought out by GE, and then sold to Computer Vision. Later on, I moved to Intergraph. And then finally, before I started MecSoft, I was at Unigraphics, which is now Siemens PLM. So CAM has always been my passion. So here we are with our latest VisualCAMc, which we're about to see.
And next up is Uday. Uday, why don't you say hi?
Hello, everyone. My name is Uday. I'm with MecSoft Corporation since 2005. I've been a technical support manager at MecSoft. I hold a master's degree in CAD/CAM in industrial engineering from Arizona State University, and I'm really excited to be in the CAD/CAM space.
Excellent. So, guys, I'm going to just push the button, so it's all yours.
All right, okay, so let me jump in, and I'm not sure how many of you in the audience are familiar with MecSoft, so I just want to give a brief introduction about MecSoft. Many of you might have heard of us, but for those of you who haven't, this is a brief introduction of what we do. We're actually a developer of computer-aided manufacturing, CAM software products. You probably all on the webinar know what's CAM. Running on the cloud as well as the Windows desktop for manufacturing parts in a wide variety of industries. We've been in business for over, this is actually our 20th year being in business, so we know a thing or two, like the ad says, the insurance ad, about CAM. We also consider ourselves as our customer's CAM partner. What we mean by that is when we sell you a product, we're not just not going to sell you and run. So we are there to support the product, support you with post-processors and training and all of that. So we're a full function house, CAM house, so you can rely on us not just for the technology, for the CAM technology in the product, but also any after sales support and upgrades and things of that sort. So Joe, please go to the next slide. About MecSoft, like I said, we started in 1997. We were a California corporation based out of Irvine, California, which is in Orange County. We have customers in over 50 countries now, and when I say customers, these are primarily our desktop customers. So we started out in the desktop market, and we're still in the desktop market. We're strong there, very strong with multiple products, and we have desktop products in over 6 major languages, and we have representation in all the major markets in the world. So some of the desktop products that we have, VisualCAD is a free CAD modeler that we support. That's our standalone VisualCAD, and that comes with 2 CAM products. One is called FreeMill, which is basically a free milling product running on top of VisualCAD, and then VisualCAM, which is our full function commercial CNC programming product that runs also on VisualCAD, and we consider that as a complete standalone VisualCAD CAM product. We do have other products as well. We have RhinoCAM. If you've heard of RhinoCAM, that's our product as well. RhinoCAM is actually VisualCAM running inside of Rhino, a completely integrated plugin inside the Rhinoceros NURBS modeler. Then we also have VisualCAM running inside of SolidWorks, and that's called VisualCAM for SolidWorks. And so we have taken our core CAM technology and ported it into different CAD systems. And now our latest foray is on the cloud, which we are working with Onshape to introduce the VisualCAMc product. As far as our product modules and our technologies that we have in our CAM products, milling, of course, that's our bread and butter, our flagship technologies. We have 2.5 axis all the way up to 5 axis continuous CNC milling represented in all of our desktop products. Turning, we have 2-axis CNC turning as well. And then in selected products like RhinoCAM and VisualCAM, the standalone VisualCAM, we have parts nesting and also mesh processing and 3D printing, as well as artistic modeling the components. And you can mix and match these when you buy our desktop products. All right, Joe. As far as the industries, we have a wide variety of industries that our products are represented in. Production machining, woodworking, furniture making, mold and die making, aerospace and automotive, that's more in the 5-axis space. Music industry is very large for us. People, luthiers, were making musical instruments of any sort, guitars, ukuleles, and things of that nature. Jewelry and artistic machining, prototyping, and education. Education is pretty strong as well. So these industries represent our desktop products, and also I would assume as we start getting into the VisualCAMc, the cloud product, we would find strong representation in these industries as well. So Joe, if you want to, okay, just to give you an idea about the perpetual licensing model that we use in our desktop products and also the pricing, so you get an idea of how VisualCAMc pricing might play out, because we still haven't decided completely on the pricing. It's VisualCAMc is still in beta. We have 5 configurations, the Express, starting from the Express, Standard, Expert, Professional, and Premium. Starts at $595 all the way up to $10,000 for the full-fledged. The Premium configuration, which includes all the way, which includes 2.5 axis all the way up to continuous 5-axis machining. Okay, now let's talk about the cloud product, which is what this webinar is all about. VisualCAMc is the cloud product. It's the name of our cloud product. It's a CAM application on the cloud that allows users to create 2.5 axis and 3-axis milling cutter pads. We've kind of restricted it to just 2.5 axis and 3-axis milling at present. So that will be our first release that includes only 2.5 axis and 3-axis milling. And it works on any of the Onshape part documents. You would be able to generate these toolpaths, milling toolpaths on any of the Onshape part documents. And fundamentally it uses the MecSoft's desktop CAM technologies, which have been proven in the industry for about 20 years now. So basically we have the same technology running on the server, but you're interfacing to that MecSoft VisualCAM technology through the web browser. And currently, beginning of the year, we released the free public beta software, so it's currently free, and anybody who has access to an Onshape account can download this application and run it free of cost until the beta expires, which will be somewhere. Our current plans are the commercial release is going to be somewhere in the summer of this year. So that's what we're targeting at this point. So without any further ado, I'll hand it over to Uday for a demo.
So Uday, let me make you presenter, and you should have a message saying share your screen.
Yep.
Cool.
I hope everyone is able to view my screen. Hello everyone, good morning, good afternoon, or good evening, and thank you for joining us for today's webinar. Today we'll be talking about VisualCAMc, the full cloud-based CAM application for Onshape. So as you can see, I currently have a part modeled in Onshape, and I'm going to go into VisualCAMc by selecting Add an Element and choose VisualCAMc. So this will automatically launch a new tab right next to your Part Studio tab in Onshape document, and you'll see that the part is loaded into VisualCAMc, and the interface, the CAM interface, appears right in a browser. So I'm running on a Chrome browser, so you could be using any browser, any operating system, and you can program your toolpaths directly from a web browser here. So the typical workflow in VisualCAMc is working your way from left to right as you access these menus. Your CAM browser appears over here on the left pane, and the first step is to define your machining process. So you would go to Machine, and you would select the coordinate system for machining, and by default the coordinate system is oriented in the same orientation as the world coordinate system as you have established in the part. So you can specify the orientation and then select Save, and this establishes your XYZ orientation, or the coordinate system orientation, for milling this part. And the next step we're going to do is select our post processor in here. So we go into Post, and we can select a post processor that you may already have pre-selected, or you can choose from a list of post processors in here, and you can pick one from the list. So we currently have over 300 different posts that are included in our standard post library. So I'm going to pick a post in here, select Close. The post processor is set to a Fadal CNC machine, In the next step, we would want to go ahead and build our stock material. That would be the workpiece you're going to be selecting or starting with to machine this part. So selecting stock displays your stock dimensions in here. You can see the X, Y, Z extents are automatically computed based off the part geometry that you're working in, and you can also specify offsets in X, Y, or Z. And in this particular example, I'm going to add a 50 thousandths offset along the Z-axis. So we would like to first face it down so the material can, the part can be, stock can be faced down to the height or the thickness of the part. And you'll see that the stock is now displayed on top of the part, and there's an additional 50,000 stock being left in here. In the next step, we're going to establish the work 0 or your work coordinate origin of the program 0, and this can be done by selecting work 0. And in this particular step, you can set the origin to your stock box, or you can set it to the part extent, which is the part box. We're going to pick set to stock. We'll pick the 0 face to be the highest face, the top face of the stock, and for the 0 position, I'm going to choose the southwest corner, which would be your lower left corner. So you'll see that the coordinate system triad appears at the top face of the stock and the southwest corner. And selecting Save creates your work 0 and is listed in your machining browser under the machining job. We are now ready to program our toolpaths in here. So under the Tools tab, we have currently a set of tools loaded, and we'll go through the programming steps here. So as this part is prismatic, where there are no sculpted surfaces or sculpted bottoms, we're going to use a 2.5 axis or 2-axis programming method to machine this part. So I'm going to go into 2-axis, first start with the facing operation in here. And under the facing operation, I'm going to pick a tool. I'll pick a face mill. I can always double click to make edits or changes to the tool in here and hit save to save the changes. Establish my feeds and speeds, set the spindle speed, cut parameters, your cut feed rate, engage and retract feed rates. And you can always set these parameters for each and every operation that you're working on in here. So I'm going to set my cut feed rate to be 20. I'll change the engage to be 10. We'll read the retract at about 40 inches per minute. In the next step, you can establish your clearance, which is your safety plane or the safe Z height for transfer motions. I'm going to leave this as automatic. And then we'll establish our cutting parameters where you can set your tolerances, your stock allowance, your cut patterns, your cut directions in here. You can also control your step overs and all the additional parameters. You can also establish your cut levels. And I'm going to pick this boundary here by right-clicking to select a chain, so it automatically picks a chain of face edges from the part. And then we'll establish our entry and exit. I'm going to establish the entry and exit using lines and arcs, specify the parameters for these as well. And you can also set your exit parameters under the exit tab and pick generate to compute your toolpath. So your toolpath is now being generated on the cloud and delivered back in real time. As you can see how quickly, how fast we were able to compute the toolpath. So there's the scalability available to you based on the complexity of the part. So selecting simulate will provide you an animation of your toolpath we just programmed. So there's our facing operation. The next thing I'm going to program is a pocket operation. So as this is a step pocket, I'm going to use a 2-step process, use 2 different pocketing operations. In the first pocketing operation, I'm going to pick a tool. We'll use a 3/4 inch end mill for the pocket operation. We'll specify our feeds and speeds, clearance, and then go into the parameters. The workflow is exactly similar to what we did on the previous step, the establishing of feeds and speeds and clearance. Now I'm going to right-click on this edge to pick a chain, so it automatically auto-chains the face edges. Specify the parameters for your pocketing. You can set your tolerance, your stock allowance, and then here you can choose from the different cut patterns. I'm going to use the high-speed cut pattern. This is like your adaptive cut pattern, also known as tricaudal cut pattern, so we call it high-speed cut pattern. Specify your cut direction. Control your step overs in here. You can establish your cut levels, where you can specify your total depth. Your depth per cut can also be set right in here, and selecting generate creates your toolpath. So your pocketing toolpath for the first step of the pocket is generated. We'll go back and repeat the pocket operation again to program the next level in here. We'll still use the same tool, so you can see the tool is pre-selected. I'm going to use in the cutting parameters, I'm going to pick an offset cut pattern in here. In the cut levels, I'm going to pick the face edge at the bottom of the pocket, which is at the floor of the pocket. So right-click will select the edge, chain of edges, and then pick generate toolpath. So the toolpath is computed, and the toolpath is previewed once it's generated. In the next step, we're going to program these holes in here. So we'll use a hole profiling operation under 2-axis. We'll pick hole profiling. I'm going to pick a 1/2 inch end mill, establish my feeds and speeds and clearance. In the cutting parameters, we could specify the cut conditions in here. We can select these two hole features, specify the hole depth, and any additional parameters, where you can also control the helix parameters, and then pick generate to compute your toolpaths. Now finally, we're going to program a drilling operation to drill those 4 holes on the top face of the part. We'll select hole machining and drilling. We'll pick a tool for drilling in here. So I have 2 different drill tools loaded. So I'm going to pick a 1/4 inch drill, establish feeds and speeds and clearance. Under cutting parameters, I can specify the drill depth. And I can also select the type of drill, whether you want to program a standard drill, deep drill, countersunk, break chip, or you can even have user-defined drill cycles. I'm going to go with the standard drill in here and select the drills by selecting the features by just picking the edges of the hole right here. So I have those 4 holes selected. I'm going to add tooltip to drill depth, so it'll actually compensate for the tip of the cutter to make it a through hole. I can also apply a sorting in here to sort the drill in a sequence, and then pick generate. Your toolpath is now generated. You can run a verification in here, right-click simulate, and there's your verification toolpath animation. Now you could post each of these operations out individually. If your machine does not have a toolchain, if you need to post them individually, you can right-click and select post process. Your posted code is automatically downloaded to your computer, and there's your posted code for the drill cycles. You could also post all the operations to one posted file. Just select the setup, right-click on the setup, and select post process. This would automatically download your posted output file, and you'll have all the operations with your tool changes, starting with the first tool and all your subsequent tool changes. Now the posted code is now ready to be transferred out to your machine controller. Now let's take a look at one of the complex geometries in here where we have already some toolpaths programmed. So I'm going to go over to this example in here where you can see this part has several different features. We have a roughing toolpath where you can see that the feature is faced with a high-speed cut pattern in here. You can see the complexity of the parts that can easily program in VisualCAMc. We have programmed pocketing operations, chamfer operations to program the chamfer on the part, hole pocketing for programming these hole features in here, and drilling as well. So depending on the complexity of the part, the servers are automatically scaled up and scaled down based on the complexity of the toolpaths that are involved automatically without demanding you to have a very high-end hardware system running on your end. So there is a wide range of different toolpath methods that we offer in 2-axis methods. We have 2-axis facing, pocketing, profiling, V-carve roughing, V-carving, engraving, slot machining, chamfering, fillet milling, hole pocketing, hole profiling, thread milling, and T-slot machining. All of these methods are available in the 2.5-axis in the VisualCAMc beta. You could all sign up for the beta and try it out. In the hole machining operations, you have drilling, tapping, bore, and reverse bore methods.
There was a question that came in on how you can face stock. Maybe you can show them the facing operation.
Sure. I'm going to go back to the part we programmed. So if I would like to face this stock material in here, we have a facing operation that we programmed. So we pick the face edges around the extents of the part, or you could even select a sketch that you may have drawn in your part modeling in Onshape, and then you can select the sketch or the chain of face edges as your part geometry, specify a tool for your facing operation, and you can establish your cut pattern in here. You could go with either offset cut pattern or a linear cut pattern, which could be like a lace cut pattern, and then generate your toolpaths. So this
I think the idea is what happens if the stock, like So you have a stock that you want to select the stock, not the actual geometry. So what if you have an open profile for the actual geometry? Does that make sense?
Yeah, you could program it as a roughing operation.
Yeah, but do you want to, you got to create a sketch or something to give you that size of the stock, because you actually want it to pick the stock, not the part profile.
Yes, you could create a sketch that represents the extent of your stock and then program a facing operation.
Yeah. I mean, that's that is the way to do it, right? If the profile doesn't lend itself to the outside of the stock.
Yes, that is one of the ways to do it, or you could use a 3-axis roughing operation where it automatically takes into account the stock and the part geometry, and you can use that as a facing operation as well.
Got it.
So in this particular example, we used a 3-axis roughing operation where this creates like an open pocket in here to face it, as well as to machine it down to the floor of the part. Okay, so the next thing I would like to cover here is 3-axis machining in VisualCAMc. To demonstrate this, I'm going to go ahead and bring in a part which we have a core mold. As you can see, the part here has sculpted surfaces, you have drafts on the part, you have fillets. So parts like these can be very efficiently programmed using a 3-axis machining operation, or 3-axis, where all 3 linear axes can move simultaneously. So the workflow is very similar. So once you have your part modeled in Onshape, you just select the element, go to Add Application, select VisualCAMc, and the part is automatically loaded, and into the VisualCAMc it appears as a new tab within the same document in Onshape. So once you have your part loaded, we would define our machine tool coordinate system, where you can establish your X, Y, Z axis orientation. In this particular case, I'm going to set it to the world Z, select Save, and then we'll establish our post processor, very similar to how we chose for the 2.5 axis part. So I'm going to pick a post as a FANUC controller here and pick close to accept it. We'll create our stock material, so I'm going to choose calculate from geometry, and the stock is automatically computed and previewed in the viewport. And you can see the extents of your part as well in XYZ coordinates. In the next step, we're going to establish our origin, so which could be your work 0 or your work coordinate origin, or also known as program 0. I'm going to pick set to stock. We'll do highest Z and southwest. So your XYZ origin is being set to the top face of your stock material and the southwest corner, which is your lower left corner. Now this could also be called your work coordinate offset. In some machine controllers, called like G54 or G55, your work coordinate offset. In the next step, we're going to program toolpaths in here. So first step is to rough it down to bring it as close as possible to the finished shape of the part. So we're going to do this by selecting 3-axis and Z-level roughing. And this displays the interface for the Z-level roughing, where you can pick your tool. So I'm going to pick a 1/2 inch end mill, establish feeds and speeds in here, where you can specify the spindle speed, your cut feed rate, engage and retract feed rates for the roughing operation. Establish your clearance plane, and then in the cutting parameters you can specify your tolerances, you can specify your cut patterns in here, you can choose your step overs, and in this particular case we have the option to automatically choose between cavity and core. So as we have the use facing cut patterns for core region selected, VisualCAM will automatically identify core and cavity areas based on the part that you imported in here or you modeled in for machining, and it identifies this as a cavity and everything around the core areas in here. So it uses a facing cut pattern for the core regions, and you can specify your step overs for both core and cavity regions. Establish your cut levels, where you can specify your step downs. You can specify how fine you want the cutter to step. Any additional parameters like your entry and exit, so you get all the precise control that you need. And then selecting generate computes the toolpaths, and the toolpath is computed on the cloud and delivered back to you. You can see in real time how quickly we were able to generate these toolpaths. So depending on the complexity of the part, it could take anywhere from a few seconds to a couple of minutes. So we have the roughing operation computed in here. You can run a verification, right click and select simulate, and that'll allow you to run a cut material or the toolpath animation. At any time you can select pause and pick exit to end the cut material animation in here, simulation. In the next step, once we are through with the roughing process, we want to go with the pre-finishing process. So we could use a parallel finishing process. I'm going to use 3-axis and parallel finishing. Typically for a finishing process, you would want to use a tool that has like a ball mill or a corner radius tool. So I'm going to use a ball and mill, establish feeds and speeds and clearance, very similar to what we did in the other operation types. And now here you can specify your cutting conditions for finishing. You can also contain your tool paths if you'd like to by selecting a chain of edges. I'm going to right click and pick the chain of edges in here. Specify your cutting conditions where you can control your direction of cut. You can also control your step over parameters and then pick generate, compute your parallel finishing toolpath. The toolpath is generated and delivered in a few seconds. You can run an animation in here, right click and simulate performs the animation of your toolpath. So there's your parallel finishing toolpath. You could do a combination of both 2.5 and 3-axis machining operations. Now once the toolpaths are computed, you could post-process. You could post-process each operations out separately if needed, or you could post-process all of the operations out to your machine tool as one operation by right-clicking on the setup and then posting it out. So in this particular example, I just posted out the parallel finishing operation in here. And there's your posted output file. And this is now ready to be transferred out to your machine tool. To post all operations, you can select setup, right-click, post-process, and this will automatically post-process your toolpath and download the posted code down to your computer. And there's your posted code. It starts with your Z-level roughing operation followed by the finishing operation in here. Now let's look at a few complex parts in here, how VisualCAMc is able to easily, effectively program these parts. So I have another example in here where it's a cavity mold. And we have programmed a few operations like a Z-level roughing operation which does roughing in levels. We have a parallel finishing operation which can be used as a pre-finishing or finishing operation. And I also have a Z-level finishing operation in here which does finishing in constant Z levels. Now under the 3-axis methods, we have additional operation types, a Z-level roughing, Z-level finishing, a parallel finishing, radial machining, and spiral machining. So depending on the type of geometry you're working with, you could choose these methods accordingly for programming these parts. Now let's talk about tool libraries and also post-processing. So in VisualCAMc, you could define tools by going to the Tools tab, which can be accessed right next to the machining job. You can create tools of different types. We have ball and mills, flatten mills, corner radius tools, tools for engraving, chamfer, taper, face mill tools. You all can also define dovetail cutters, fillet mill tools, lollipop tools, and of course you have the different drill tool types, standard drill, center drill, reamer, tap, bore, and reverse bore. Now each of these tools can be defined. You can specify the properties for the tool where you can set your tool numbers, your height offset register numbers, and also any comments that you'd like to output, and the coolant types as well. Once you have defined these tools, you could save the tools. You can export them to a library. So exporting them to a library allows you to reuse the same tools or the library of tools that you built on other projects. So you can go under the Tools Libraries section, with the lower half section of the Tools tab, and you can select Import Tool Library. So once you select an Import Tool Library, the library that you imported appears over in here, and you can have one or more libraries selected. And the library that you select is now being displayed, and you can drag and drop tools from the tools in library to the tools in the document. So for example, if I want to go back and refinish it with a quarter inch tool, I can select the ball mill quarter inch which I have in my library. I can drag it and drop it to the tools in document. Now I can switch back to my machining job and add another operation in here. I could do a 3-axis Z-level finishing, and I can use the tool that is loaded from the library in here and generate the toolpaths for it. So you could create your own tool libraries and make those tool libraries available on all the other documents that you'd like to program using VisualCAMc, so you don't have to recreate the tools over and over again. Now let's take a look at post-processing. We could load post-processors. We can bring in custom post-processors into VisualCAMc. Now these custom post-processors you may have created using our desktop product, and if you're currently using our desktop product and would like to bring in those post-processors into VisualCAMc, you can select your post option in here, and you can choose the option called load from files. So as you select load from files, this would allow you to browse for a tool library from the files. I'm going to go into the folder where you have your post saved, and I can go ahead and select a post processor in here. I'm going to choose a OSI controller and select open, and you'll now notice that the post gets automatically loaded in here, and then when you hit close, it automatically accepts the post. So this is how you can easily load post processors that you have custom edited and custom built from our desktop product and bring them in. You can also load the other default posts that are included in the VisualCAMc by default as well. So this gives you a quick overview of how you can program using VisualCAMc, generate 2 and 3-axis toolpaths, being able to bring in custom tool libraries, build your own tool libraries, and also custom post processors. Now, you might be wondering, how can I get access to VisualCAMc? How do I, if I have subscribed to Onshape already, how do I access it? So if you go to the App Store over here, you can click on App Store from your document in Onshape, and in the App Store, you'll see that under all apps, you'll see VisualCAMc up here right in here. You click on VisualCAMc, and then you can click on subscribe, and this will subscribe you into VisualCAMc beta for Onshape. Now once you have subscribed to the app, you can access the app from your document in Onshape. So you go into your document, your Part Studio, you click on Add a New Element, select Add Application, and you'll automatically find VisualCAMc once you have subscribed to the app. So selecting VisualCAMc will automatically load VisualCAMc as a separate tab within Onshape, and you can access these app. You can access VisualCAMc and generate your toolpaths from Onshape. Now we also have a lot of resources for you to get familiar with VisualCAMc. You can access the help system in VisualCAMc by selecting the drop-down right next to the help. Click on help, and this automatically brings in the help system where you can learn about the different toolpath methods. You can learn about how to create your stock. Each of these help topics are added in here, and you can access each of these help topics directly from a single click of your web browser from the VisualCAMc tab. You can also learn more about the product by going into product page, and this will take you to MecSoft VisualCAMc page on our website to learn more about it. You can also access a lot of videos and resource tutorials by accessing videos from the help menu. This will take you to MecSoft's YouTube channel where you can access all of the VisualCAMc videos in here, and you can provide us feedback about your experience with VisualCAMc by selecting feedback from the help menu. If you have any questions, I would be more than happy to. Sir?
Well, what platforms will this run on today, and how much do you have to download and install?
Well, there's no download or no install required. It works on Windows, Mac, or any operating system as long as you have a web browser that you can access it from. As I mentioned, there's no download required or nothing to install, so you just have to sign into Onshape and then just subscribe to the app to get access to VisualCAMc.
And you guys are on a, I was kind of loaded question, but so no one's done this before. This is really the first time in the market where you can do your subtractive manufacturing, without worrying about dongles or without installing or without downloading stuff. It really is pretty cool. And this is beta, so you are updating this on a regular basis too, right? I mean, this is on a very rapid development plan.
Yes, that's correct. We have more enhancements coming down the road. Actually, right after the webinar, we'll be updating a few of the functions. We actually have graphical picking for Z heights and things of that nature.
Oh, good.
Coming in, next week. And
how do you tell? Can I ask? Is there an obvious way to? I should know the answer to this. This is actually my question. Is there a version? Is there a way to tell when you've made updates, like in the product itself?
Yeah, Uday, can you show that? Actually, maybe you can't show it now, but what will happen is if you have logged in after an update was pushed, you will see a little tooltip that comes up on the bottom right corner, just like Onshape. They'll tell you that the new version.
It's an in-app message then. Okay, cool.
Right. Yeah.
Yeah, this thing is great. I mean, sorry, I'm not the one supposed to be asking questions, but there's a question about tablet. This is a limitation of Onshape, not of MecSoft, would be my guess. Right now, any integrated cloud app, there's on iOS or on Android, you're using the Onshape app, so the little download that you do in Onshape. And for now, it's temporary, but for now, we're not allowing the tabs to open integrated cloud apps on those mobile apps. We will address that. I would imagine that if MecSoft was interested in having kind of a standalone product that ran on tablet, looks to me like it probably would run, but I don't know if that's a priority at this point.
We've basically targeted the web browser at this point, and so that's really, at least in the near future, that's what we'll be focusing on.
The challenge too, and the reason why we're blocking it on purpose is that a browser on the tablet doesn't necessarily mean you've got the best experience because you're talking about fingers and touch, and that's why we built an app on top. We built an app to handle the touch. And so we're some apps will actually work really well, but they tend to be the applications that don't require a lot of interaction. And when you're talking about selections and all of the stuff that you would do here, we'll have to come up with a strategy of how to make these work. And probably there'll be, my guess is what we'll do is kind of a certification process of how to get each app that will work with fingers and stuff like that. So but it does work on Chrome, any browser, Chromebook, Linux, Windows, Mac, anything with a browser.
Right.
I think that's about it. We've been answering the questions interactively here. Unless anybody has more questions, it's always nice to finish this a little early. I have a question. I'm going to ask another poll, kind of ad hoc poll. How about, how many of you have actually used VisualCAM yet? Why don't you raise your hand if you've used it or tried it, VisualCAMc. So I see a few hands. So how many of you are going to try it? Let's try it that way now that you've seen it. All right, a lot more hands. Every one of you in this webinar, you could try it right now. There's nothing keeping you from going over to the App Store, and you could have actually been following Uday in this session. We could have invited you in, and you could have followed along interactively in the same model, actually. So go give it a shot. You've got it's in beta now, so there's absolutely zero barriers from using this thing and really digging in. If you look at all the stuff behind me, these are all VisualCAM. Not that it's not a variety. I'm obsessed with our logo, but I've machined our logo out of every material using VisualCAM at this point. Except for
we're definitely looking for feedback. So the more of you that go out and try it, and this is a great time to put in your requests, and then before commercial release. So yeah, and we basically listen to our customers.
I mean, it's very what's the right word for it? It's beta, but you're able to do production. You're able to get a lot of work done. I mean, I think it's a pretty mature beta. Maybe that's the best way to say.
Yeah, the beta part is really the interface. Really, because the underlying technologies are desktop technology, which is 20 years been proven in the field for over 20 years now. So, yeah, the toolpath generation is pretty robust. It's really the interface with the servers and the latency issues and things of that sort. That's what we're dealing with at this point.
And also, another question that did come up, might as well say it, is that when you do make a change to the Onshape model, you guys do handle the updates. You say if you saved your data in Visual C, it will update the toolpaths, correct?
It won't automatically update it. You'll have to regenerate it. We will flag the
right, but it's you're able to update manually. I should say, yeah. It's important to save, though. I think that's the trick, isn't it?
Yes, that's correct. Yeah.
That's what the save button will allow you to have that persistency later, Philip. All right. If anybody else has questions, now's the time. We'll give you a couple more minutes. Quite a few of you are here, so I would suggest go sign up.
There's a question here from Philip that says, "How do I save?" There is actually Uday, if you want to show that save button up there.
The big save button. Yeah.
So it's right on the, right just above the machining browser. You'll find it right next to the load button. There's a save button. And you can pick save to save all of your CAM data into the same document.
This is a great question about the versions. And yes, versions are supported. If you've saved it, if you save this data when you version Onshape because it's saved in the Onshape document, you are saving this version of your toolpaths as well. So the answer is yes, this does support the versioning in Onshape. It's the whole point. I think that's it, guys. Unless you want to do anything else, I'd say we can wrap this up.
Okay, I think we're good.
Awesome. Well, thank you, everybody, and I will hope that I hit the record button because I just realized I bet I didn't. So that will be perfect. If worst case, we'll put a video of MecSoft on the for the webinar. Okay. So
I noticed, Joe. I noticed you hadn't turned it on, so I hit the record button, but that was about 50% down the.
Well, listen, sorry. Thank you for doing that. Because last time I did it, I started it too early and everybody got mad at me, so I forgot to hit start. But we've got plenty of material we'll put in there to point them to. So, all right. Thank you.
Thanks, everyone.
Thank you.
Bye-bye.
Hey, Joe, why don't you send me the, when you save the recording, give me a link to it or send it to me so that then we can post it, okay?
Okay.